Hey everybody, it's Hutch. How you doing? This is your Module 10 Sampling and Statistics Practice Test. Let's go ahead and take a look at how to do each of the problems. All right, so starting with Lesson 1, this is all that concept of, is the surveying method a valid sampling method or invalid? Okay, basically biased, unbiased, that kind of thing. All right, so notice that it says in the directions you must highlight the part that is important. So a survey is sent on Facebook. Okay, this is the part that makes this one invalid. Okay, you can't send a survey and just use the results of people who want to do something. Okay, all right, surveyed every fifth person. Okay, this is a valid method of sampling. Okay, because it's random. You're not choosing who you're surveying. Okay, all right, next one is the girl surveyed people at her lunch table. That's that convenient sampling, and that is invalid. You can't just do a small convenient group. And then we have the last one. The computer randomly chose 100 people. Computer-generated sampling is a valid method. Okay, that's that simple random sample. All right, let's go ahead and take a look at Lesson 2s. Lesson 2s are using proportions to make predictions. So I'm going to get my highlighter ready. Out of 38 people surveyed, okay, 14 said they would buy jeans, and buy is spelled wrong, but you can, there you go. How many jeans should the store purchase if they are predicting 1,450 people? This is what we're predicting, and notice it also says round to the nearest whole, so we have to pay attention to that as well. All right, let's go ahead and write our base ratio. So our base ratio is 14 out of 38 people, and we're going to set it equal to what we're predicting, which is 1,450 people instead of 38, and this is going to be X. So first option is to find the multiplier, okay, and so I can wonder 38 times what is 1450, so let's go ahead and try that and divide by 38. And we get a repeating, or we get a non-terminating decimal. It's not repeating. And so we can't use the multiplier method. We're going to have to cross multiply. And so if we cross multiply, we have 38x equals, and then our next cross is right here. And so we have 14 times 1450, and we end up with 20,300. Let's go ahead and divide both sides by 38 to isolate that variable. And we end up with x equaling, if we divide by 38 here, 534.2. It says round to the nearest whole, so 534. All right, now we need to actually answer the question. How many jeans should the store purchase if they are predicting 1,450 people? The store should purchase 534 jeans. Okay, all right, let's head over to this problem. Make an accurate prediction based on the valid data collected. All right, grab our highlighter, and here we go. The guidance department did a random survey, okay, which is valid, and found out that 26% of students plan to take French. Predict how many students they should plan for the French class if there are 780 students, and round to the nearest whole. Okay, so let's go ahead and set up our base ratio. So here's our base ratio right here, 26%. As a fraction, that's 26 out of 100. And we're going to set it equal to what we're predicting. Okay, and instead of out of 100 students, we're predicting out of 780. And let's go ahead and solve for x to determine how many people we should predict to take French. Okay, so let's go ahead and test if there's a multiplier. We know there is, because 780 divided by 100 is 2 swoops to the left like this. So my multiplier is going to be times 7.8 over 7.8. Okay, and when we do 26 times 7.8, we get 202.8. Okay. And then it says round to the nearest whole. Okay, so we can go ahead and answer the question now. How many students should they plan for the French class? They should plan for 203 students to take French. Okay, and there we go. Okay, all right, let's go ahead and take a look at number 7. Number 7 is all about the mean and mean absolute deviation and variability. It says each dot on the dot plot represents the mean number of dogs at shelters all over the state. Okay, so if I want to find the mean of that data, remember mean is we take the sum of all the data and divide by how many pieces of data there are. Okay, so we're going to go ahead and add these up. Okay, and we have 6 plus 7 plus 8 plus 8 plus 9 plus 9 plus 9 plus 10 plus 10 plus 11 plus 12. Okay, and we get 99. So we have to write our sum up above, divide by 11. Okay, this is me showing my work. Divide by 11, and so my mean ends up being a mean of 9. And that makes sense because we have symmetrical data here. Okay, all right, let's go ahead and find the mean absolute deviation, okay, also known as MAD. And remember, mean absolute deviation is how far off all the data is from the mean, okay, on average, okay? And so we do need to use this to make some notes here, okay? So we know the mean is 9, okay, and that's right here. So how far is everything off of that? Well, we have 0, 0, 0. We have 1 and 1, okay? Another 1 away and 1 away, 2 away, 3 away, 2 away, 3 away. So that's the absolute values of how far everything deviates from the mean, okay? Let's find the average, okay? And so we're going to add all those up. So we have 3 plus 2 plus 1 plus 1 plus 1 plus 1 plus 2 plus 3. And we get a total of 14, okay? We didn't need to say plus 0, it would still be 14. But we do need to still divide by the 11 pieces of data. Okay, so let's write down that there's a total of 14 divided by 11. And let's find the mean absolute deviation. So it's 1.27 with the 27 repeating. Okay, so what does that mean if it's just 1.27 off on average? Circle to describe the variability. If it's under 2, I mean, it's pretty close to 0. I wouldn't say it's too far off. So we're going to go with low variability. Okay, so we're going to say anything that is less than or equal to 2, we're going to choose low variability. It's not really that spread out. It's pretty surrounding the mean, okay, in our dot plot. Okay, all right, let's go ahead and take a look at the distribution. So this is lesson 4, okay, and we're analyzing how is the data distributed, okay, so we can figure out how to analyze it. Okay, and so if we look at this data, it is really all scattered everywhere. There's no like middle with equal things on both sides. It's all over the place, and so this is what's called asymmetrical. Okay, A, remember, means not. Okay, all right. Let's take a look at number 9 for lesson 4. This is analyzing and looking at this double box plots, okay, that are stacked on each other like this. So let's go ahead and answer some of the questions and see how you are analyzing box plots. So what is the median? Remember, median means the middle piece of data. So the median of 7th grade is at 10. Okay, here's the median. What's the median of 8th grade? That's at 20. What is the IQR, interquartile range, okay, of 7th grade? And remember, that's taking the Q3 minus Q1, okay? And so we have the 20 minus 5 equals a range of 15. And then the IQR for 8th grade is the 25 and the 15. So we have 25 minus 15. If you're not sure, because it's a test, you should be doing this so you don't make any silly mistakes, okay? So that range is 10, and you can see it's a smaller range of data, okay? All right, what percent of 7th grade's data is between 5 and 20? Well, so we're talking about between 5 and 20 here. What percent of data are those two quadrants? Well, each quadrant is 25%, and we have two of them there. So this is 50% of the data, okay? All right, let's go ahead and guess what? That's it. There's no more. So that is your practice test for sampling and statistics. You're all set with that, okay? All right, if you have any questions, let me know. Otherwise, good luck.